week 7 or day 2 of the unit 3 where we're talking about cardiopulmonary responses. And so we're going back to mean arterial pressure. And so here are the 3 outcomes for this little lecture. So we need to have some definitions. So remember, flow is calculated. I guess this really isn't a definition, but more an equation. So flow is the pressure gradient divided by the resistance. So in the cardiovascular system, flow is cardiac output. And remember, flow is how much of a liquid or substance is moving, volume per minute or per time. Pressure in the cardiovascular system is mean arterial pressure. We don't really have to worry about the pressure gradient because blood that returns to the right atria essentially has a pressure of 0. So anything minus 0 is that thing that you were subtracting. And then you've got resistance or total peripheral resistance. And so we can calculate mean arterial pressure a couple of different ways. But when we're talking about mean arterial pressure, we're talking about pressure, the average pressure in the arteries. We're not talking about pressure in the heart or the veins or the capillaries. We're talking about pressure in the systemic arteries. So we can calculate this either 1/3 systolic plus 2/3 diastolic, or heart rate times stroke volume times resistance. There are a couple other ways to rearrange this top equation. I'm not going to get into all of them, but just know that this is not the only one. I just like this one because you're in systole for 1/3 of the time and diastole for 2/3 of the time. So under pressure, and I'm not sure if you'll get the little picture here. If you do, great. If you don't, great. So like I said, MAP is the average pressure in the arteries. So systolic blood pressure is the maximum pressure in the arteries. It is caused by and occurs during ventricular contraction. It is directly affected by heart rate and stroke volume. So if it's caused by ventricular contraction, the more frequent the contractions and the harder the contractions, well, I'm going to have a higher pressure. Diastolic pressure, on the other hand, is the minimum pressure in the arteries. This occurs when the ventricles are relaxing, but it is not caused by the ventricles relaxing. Let me say that again. This occurs when the ventricles are relaxing, but it's not caused by the ventricles relaxing. Instead, it's caused by the elastic recoil of the arteries. Think of your arteries like a balloon. You fill up a balloon, you let go of the end of the balloon. What happens? The balloon recoils. There's pressure in that recoil that causes the air to fly out. Okay? And so diastolic blood pressure is affected by resistance. So total peripheral resistance is just the resistance throughout the entire systemic circuit of the circulatory system. Okay? If we vasoconstrict, we reduce the radius of the arterioles. If we vasodilate, we increase the radius of arterioles. Vasoconstriction leads to an increase in resistance. Vasodilation leads to a decrease in resistance. Okay? It's interesting to know, and like I was telling you at the beginning, that we don't really have a pressure gradient in the systemic circulation, okay? And so just to be clear on here, when I'm talking about the systemic circulation, I'm talking about, got to get a good color here. So we're basically going from these large arteries, so there we go. So from here to here, okay? Not wanting to draw. All right, this part doesn't count or doesn't matter when it comes to arterial pressure because that's in the ventricle. Okay, notice that there's waves. So we have our 120 and our 80 in our large arteries, and there's still a gradient or a pulse in the arterioles, in the capillaries, even, really until we get to the capillaries. And then the blood's kind of moving constantly through the veins. But like I said, notice that by the time it gets back to the veins, this is essentially 0. Okay, and so the average of 120 over 80 is 93. So 93 minus 0 is 93. Okay, so that's why we don't use the pressure gradient. But notice that in the arteries, we are able to hold on to that pressure. But by the time it gets to the veins are just like, get the blood through, right? There's no pressure. It's just constant movement, constant flow, that sort of thing. All right, so actually, one more thing back there. So this is just showing that our heart is pumping blood just hard enough that it can go out our aorta, down to my big toe, back up to my right atrium, just barely getting into the heart. Like we're pushing just hard enough. We're not overdoing it. We're not underdoing it. It's just right. It's all about being efficient. Okay, so can you do these two things? Can you talk about what affects mean arterial pressure, and can you tell me what causes systolic and diastolic blood pressure? And I assure you that there will be a question asking about that on exam 3.